We'll be starting in a few minutes.
Always fun to hear from people while we're waiting to get started. Why are you interested in computer vision? Or do you have like a use case that you're looking to do right now about it? It's always really fun to hear. A lot of people, almost every time I do the workshop, I feel like people bring up building a computer vision system to monitor their cat door so it doesn't let other animals in, or it doesn't let their cat in if it has something in its mouth like a rat, which I always think is a fun use case. Someone said they've done computer vision with MATLAB, interested in new tools. Awesome. I've never done it in MATLAB. I've pretty much always done it in Python. And the Python ecosystem is awesome, especially for deep learning, machine learning, computer vision. And you say you love Python, so you're gonna love this, I think. It'll be great. Someone said using traditional computer vision. I'm assuming that means like without deep learning by traditional. Like image processing with maybe like OpenCV, some other tools. Ooh, someone said they released a lot of cool stuff. I love the manufacturing defect detection. That's actually how I got into computer vision. I was doing that at a company I was an engineer for. It was all really cool use cases though. It sounds like you did a lot. Has anyone ever labeled a computer vision data set for something like object detection before or instance segmentation? Someone said, compare synthetic data to real world data in automotive applications. That sounds cool. I love, I know there's different types of synthetic data, but synthetic data is a field I'm pretty passionate and interested about. Someone said they did lane detection badly. Hopefully it wasn't deployed in a self-driving car that was actually driving. Just for school. Nice. That sounds like a really cool school project. I wish I had that cool projects when I was in school. Greg said he has 8 GPU Lambda Lab server. That sounds fun. Don, what are you graduating in? Congratulations. That's super exciting. Now's the fun part, right? After school. He said they're losing their mind with their free time. You could go work at like a startup. I'm sure that could fill all your time, or any company really. You just got your master's in computer science out of University of Michigan Flint. Super exciting. Feel free to talk about your excitement. See, a lot of other people just joined. Any applications you want to build with it, any real world use cases you're looking to solve, let us know in the chat. It's always really cool hearing what people are working on or thinking about.
Okay, Sage, let's get started.
Cool.
Cool, awesome. So, hello everyone, and welcome to Silicon Valley's ACM SIGGRAPH and SF Bay ACM SIGGRAPH's joint chapter event. Today we'll be presenting Introduction to Computer Vision, Building Object Detection Models and Datasets with Sixgill. So before we begin, we would like to introduce our origin story. We are located in California. Our chapter started in 1982 using our Bring Our Own Tape event, where we featured our projects and events. We are one of the few Bay Area ACM chapters. We have one in San Francisco, here in San Jose, and if you go southward, we have one in Los Angeles. Every third Thursday of every month, we hold a meeting, so we always welcome members and upcoming executives to come to our meetings. And we are interested in a lot of technology topics, such as computer graphics and what we have right tonight with computer vision. So this year we have a team featuring Elliott as the chair, me, the vice chair, Elisa, I think she's here too, as secretary, and Carl as treasurer. We welcome all volunteers, so if you like what we do, and we would like to have new members coming into the team. Recently, we have several events. We had ThinVR, a VR display approach providing wide field of view in a compact form factor. We also featured academic research with Koki Nagano from NVIDIA with his AI-driven photorealistic digitization. And from the animation and production side, we also have the Evan and Sutherland's dome display, and also Gauguin's turn doodles into stunning realistic landscapes, also featuring from NVIDIA. So on behalf of San Francisco Bay Area ACMs, they are founded in 1957 and promote a lot of computing technology. And we also help create community, support networking, and hiring too. The membership fees for SF Bay ACM is only $20. And if you go onto the website, you could sign up. We also have 2 monthly meetings, one for general computing, which is on the 3rd Wednesdays of every month, and data science SIGGRAPH, which is all on the 4th Monday of the month. We also collaborate with AI Camp and Valley Machine Learning AI. So what we have upcoming is May 19th on Wednesday. There will be a COVID-19 conundrum critical insights regarding cloud security posture of enterprises. And it will be featuring Matthew Jody, Chief Security Officer, Prisma Cloud, and Palo Alto Networks. And we'll also be having a SIGGRAPH 2021 on August. So please sign up for that.
Greg Mikowski is here, does the data science SIG, SF ACM.
Well, we're looking for future speakers. And I think a lot of the topics that you're talking about with the SIGGRAPH would be good things. I'd be open to doing further joint projects. So thank you.
Awesome. I'll hand this off to Sage Elliott.
Hey everyone, I'm going to share my screen and we will get started. Just want to make sure, just let me know in the chat if you can see my screen. Just say yes or no, at least someone, at least one person, so I know that you're going to see it. All right, I see people saying yes, great. This is a intro to computer vision, building your own object detector and data sets to do that. Set up again for people who just joined in. To follow along, you really just need a modern web browser like Chrome, a Google account because we're going to use Google Colab, which is a tool made by Google. And then also you'll want to sign up for the data annotation tool. We're going to go through how to use this, and kind of all the techniques here also transfer over to any other tool you might use. And then we'll label a data set and then talk about how to pull that data set into a Python environment where you can actually train a object detection model and then run it on images and videos. So it's really cool to see what people build after this workshop. Even if they've never done computer vision before, they come away with it. And usually in a couple of days, a lot of people will share a really cool like state-of-the-art model with me on LinkedIn or Slack. What this workshop is, so hopefully it's a super friendly introduction to computer vision, kind of designed for no previous experience expected, but definitely knowing some Python will be helpful when we get to the code side. But if you haven't done a lot of Python or a lot of coding, don't worry, I will walk you through it. And there's a lot of kind of pre-written code there. So you shouldn't get stuck even if you haven't really done a lot of programming. We're going to cover applications and basic intuition around deep learning and computer vision. Then we're going to talk about how to label your own data, and then jump into code and train a model with a data set. And just keep in mind, you can't learn everything in 2 hours, but hopefully, well, I know you can learn enough to get excited about a field like computer vision, and then keep learning after this. So parts of this, depending on your experience and background, may feel fast-paced or challenging, but that's okay. I think you'll learn a lot just by sticking through it, even if a little bit might be like slightly over your head if you've never done any coding before. So keep learning after this workshop, and I'll point you to some resources after, and I'll also be hanging out for a little bit. So if you have any specific questions or resources you want, let me know in the chat. This is also going to be pretty interactive. So I'll ask questions, and you can, answer in the chat, or you can ask me questions in the chat, and I'm going to be monitoring it as we go. A little bit about me. My name is Sage Elliott. I'm a machine learning developer evangelist at Sixgill. We do really cool stuff with machine learning, computer vision, and IoT and edge devices across a whole bunch of different industries. And then we're also making tools to make it easier for everyone to build these types of applications. And for about the past decade, I've worked in software or hardware with mostly startups and agencies around Seattle, Washington, and Melbourne, Florida. It's surprising the amount of times when I say Melbourne, Melbourne, Florida, and someone in the chat says they used to live there at some point. But you can stay connected with me at Sagecodes on Twitter or LinkedIn. I'm Sage Elliott with 2 L's and 2 T's. And I'll just share in the channel if you want to follow me in any places. About you. So normally in person, I'd love to go around the room and hear about what you're working on, but it's kind of weird over Zoom, and usually the RSVP count's a little high for that. But communicate in the chat, where are you watching this from? It's really fun to see where everyone's from. And then also if you want to throw in there why you're interested in computer vision, it's always really cool to hear that. And I have a Slack channel, so I really miss staying connected with people. So I've been trying to build out a Slack channel to do this, where you could go introduce yourself in there later and share projects or ask questions. So if you get stuck labeling or training a model or something, feel free to connect with me on LinkedIn or the Slack channel and message me in either of those places. That'll be the best way to contact me. I'm saying San Jose, a lot of people down there. That's very cool. Santa Clara, Menlo Park, Bay Area, awesome. I was saying, telling some of the organizers right before we started that I really miss the Bay Area. I used to go down there several times a year, but this year I haven't been able to go down. So I can't wait to be able to travel again. Just a reminder for anyone who may have joined since the start is we're just going to be using a modern web browser and a Google account for Google Colab. And then you can just make an account here for the data annotation tool. And it's online and it's free to sign up for. There's no card or anything required. So you just sign up. I think you might have to verify your email and then you'll be able to get into the tool. So what is computer vision? It's a super big field, but I would boil it down to how computers gain understanding from images or videos. There are other data types as well that can be considered image or video. So like you've probably seen audio visualizations before, kind of like a wavelength of the audio. And that could be used as an image, and you can actually do computer vision to understand audio signals. There's also things like LiDAR, which is a little bit different, but often kind of comes into the computer vision field. And here's a little model we trained, or an example, where this is detecting trucks. This is something doing something called instant segmentation, which we'll get to in a little bit. But it's actually drawing not just like a square around where it thinks the truck is in the image, but actually the pixels that it thinks belong to the exact truck. So you can actually get really detailed understanding exactly where a truck is, or doing a kind of a best guess at it. And then this model is also detecting if a truck is moving or not, and if it's parked or stopped. And then you can measure things like dwell time from there, like how long does a truck stay at a stop. Oh no. Why I love computer vision. I think it's a really amazing interface into the world, and we're doing really, really amazing things with it today. So there's like a lot of really cool applications like actually happening in the world right now. Here's just a few that maybe you've heard about, maybe some you haven't thought about, but I was like mentioning kind of a whole variety in case you've really never thought where computer vision could be used. So more and more companies are using it across just like a ton of different fields. It's hard to think of one where maybe they're not, or where you couldn't use it. So I know a lot of you are in California. I don't know if you've heard of our small local company in Seattle called Amazon, but they have a lot of things where they use computer vision. One of them is actually, I don't know if you have an Amazon Go down there yet. You can let me know in the chat. Do you happen to have an Amazon Go or several Amazon Go's down in the Bay Area? They're a kind of like a convenience store, and they actually have bigger grocery versions where it actually just uses computer vision. And what happens is you walk in, you scan a QR code on your phone, and I think coming soon, it's actually going to be able to recognize your palm, which is even crazier. And then it kind of signs some sort of code to you when you walk in, and then you can walk around and actually just grab stuff off the shelf, and it understands what you grabbed. And then it charges you for it when you walk out the door. The first time you go, if you've never gone before, it feels like you're stealing. So like, I think the first time I went, they're like, no, it's okay, you can walk out the door. And then I'm always worried that I'm gonna get too used to that, go into another store and then just like pick stuff up and walk out thinking I'm gonna be charged for it. But that application is really cool, and I think it's going to really change kind of a lot of retail. I'm sure that other companies are also working on similar type products. They're also using it for delivery robots, delivering packages around in neighborhoods, like driving on sidewalks. It's almost like a mini self-driving car. And they're also working on self-driving cars. They bought a company last year called Zoox. And they also use it for product listings. So understanding like what images are on their market space and like, are they appropriate or do they match the product? Is there like a counterfeit image? Those types of things. Google, Google Photos, you can search your photos and, I search for a dog and it brings up all the pictures of the dogs I have on my phone. YouTube filtering, there's so much data that gets uploaded to YouTube like every minute that you can't manually filter it. So they actually have to use a whole bunch of different algorithms to do that. They're also working on self-driving cars with their spin-out company Waymo, Tesla, self-driving cars, Facebook, face tagging. These are all things you've probably kind of experienced or maybe seen around before. And then here's some other really cool use cases. And we actually work in several of these industries quite a bit. But like agriculture is one, a lot of people don't think about. But there's a lot of stuff you can do to help the agriculture side of things with computer vision, like crop monitoring, animal monitoring, and like safety of animals, construction, site monitoring, like safety again, like are people wearing their protective gear? Self-driving tractors. I know a company working on one, which sounds really cool to me, like being able to go, pick up dirt, move it to somewhere else automatically. Manufacturing, like I said at the start, this is actually how I got into computer vision, was doing quality assurance on a complicated part that like I could take it around the office, show it to different people, and I'd get different answers of if it was good or bad. And then I was spinning up product lines at some big factories, and I was like, we should just have computer vision do that for us. You can monitor things like throughput, supply chain, and then oil and gas industry is really interesting, like leak detection, monitoring for that, as well as employee safety. Healthcare, if you've ever thought about doing like X-ray diagnostics, having AI or a computer vision help you do like radiologist tests, which is pretty cool. MRI scans and medicine research. And this is by no means all of the fields using it. Like there's plenty more, but these are some that I thought were really cool and ones that maybe you've heard of. But let me know in the chat if you have a field you're really excited about or that you're working in right now where you're applying computer vision. Don said they saw a great video spotting cows. Did it happen to be one of our Sixgill videos? And we have a lot of videos with cows. Yeah, let me know in the chat there if you have a field that you thought I missed that you want to actually have people think about, or if there's one that you're really excited about. I'll move on to the next slide though, just to keep things going, but feel free to put that in the chat. So computer vision and deep learning. So someone actually mentioned at the start that they were doing, what did you call it, traditional computer vision, I think. And I just wanted to mention that computer vision isn't always tied to deep learning, but in the past decade or so, deep learning and the field of computer vision has been really dominating all those complex problems. Like most of the time when you see someone or a company share, solving some sort of problem with it, chances are it's using deep learning and computer vision. But like someone mentioned, you can actually do stuff with just libraries that do things like color extraction and like contours and lines and stuff like that without actually doing deep learning. And just to bring you at a very high level of what deep learning is and how it kind of fits into computer vision and why we need labeled data, you can think of having a function. You could think of it as a mathematical function or a programming function, however you want to think of it. And then we're going to feed that function a whole bunch of training data, and it's going to have labels associated with it. And that's actually, we're going to build a labeled data set today to do this. We're going to feed it to a deep learning model. It's going to look at all the data and the labels that we gave it, and then learn to predict the things we labeled. So today we're going to use a goose data set. So we're going to train a model to detect geese. But the method we're going to use to train it and label it is something you could do with pretty much any type of data set. So it's going to learn from all these examples and look at them like hundreds of times, pick up all the features that makes up a goose, and then we're going to give it a new piece of data it never saw before, and then it's going to return a prediction, and hopefully it's right and it's an accurate prediction. So it's going to learn from a whole bunch of data, and then you're able to feed it new data and get some sort of prediction. And I have a couple links that I'll share in the chat if you want to look into it further. We won't go too deep here, but these are kind of cool. If you've never done deep learning before, and you want to kind of see a visual representation of a deep neural network or a convolutional neural network, you can do that here. Also, I just realized that I got out of present mode at some point, so let me get back in there. Hopefully that's may be better for people. I just want to note on transfer learning. So with most popular deep learning frameworks, you can load pre-trained weights into your network. These have been trained a lot on a ton of different objects and animals. And you can then kind of take that pre-trained neural network, feed it our new data set, and it will learn much quicker. Like it'll learn how to pick up those objects typically much quicker, because essentially it's not starting from zero. In the convolutional neural network, it usually has to learn all these things like setting convolutions and understanding how to detect things like corners and lines and stuff like that. A lot of that's already done when you use a pre-trained network, and then you're just feeding it new data, and it's going to kind of adjust weights to only now look for your data set. You can think of it, again, just with transfer learning, because we're going to use it in the code. So when you see it come in, just think of it, we're not starting from zero, and then we're going to feed it new data, and it's going to adjust to work on a data set. And I'll share these slides out too, or it will be in a follow-up email somewhere. And you can go through any links I don't share. Let me catch up on chat real quick. And if you have any other questions, throw them in the chat. Someone said, starships drive around Mountain View to order food. To deliver food. Yeah, I've seen a lot of delivery food startups. I feel like now is probably a big year for more of those to come out, right? Someone said oil and gas is also doing vision work to detect the level of bad emissions in refinery flares. Yeah, I've seen and worked on some similar type things actually, where not just detecting a leak, but like how much, I guess, is leaking. And it looks like Greg did some similar things too. Very cool. Awesome field. It's like that's just like a really cool field where you can really make it a lot safer for people and the environment and everything. So it's really cool to be able to have an impact in something like that. So some types of computer vision we're going to walk through. Computer vision is a big field, but we're going to focus on some of the more just common types, again, with deep learning involved. So many of these can be combined together to, or with other algorithms to form various outcomes. And we can kind of talk about that as we go. So classification, this is where most people start. So if you've never done computer vision and you go through some sort of tutorial, chances are you're going to start with classification. And what happens is you label a data set by essentially just separating them out into different buckets. So I trained a neural network on a dog breed classifier, or with dog breeds. And so then when I fed it this data that it never saw before, this image, it predicted Labrador Retriever, which I believe is correct. But this is where most people start. And it's really cool to get started with this. But we won't go deeper here. In this workshop, we're going to start with object detection. And I think this is way more exciting personally, because it opens up a lot more doors and it's a lot more foundational to a lot of real world use cases, at least in my opinion, a lot of stuff I've worked with. So object detection can classify and localize where an object is inside an image or a video. So here it's doing the goose and it's detecting two. And not only is it saying, hey, I think there's a goose in this image, it knows there's two, and it's predicting where they are in the image. So we're going to make this today and cover how to make a data set for it. And just a note on here, so like classification can get limited, because if you had another dog in the background, like a little Chihuahua, and it's not center in the frame, it would still probably predict like a Labrador Retriever if this is kind of the main thing it's looking at. But with something like object detection, you can segment out different various objects within the same image. Instant segmentation, kind of similar to object detection. And in this little demo, you can actually see there's very tiny, but there are tiny little boxes drawn around it. And then it's also doing the same thing with the truck that we saw earlier, where it's actually predicting the exact pixels for, in this case, the bottle, and then also the water. And then instant segmentation is really cool for a couple of reasons. One is you're more precise exactly where something is. So in this case, if we wanted to, you're predicting the bottle and then the water, and then you can actually do like a volumetric calculation, being like, well, this many pixels, overlaps within the bottle here, so it would be half full, and then measure that all the way up to be like 100% full. One also thing, a cool thing that I've seen is if you've ever used VR devices like the Oculus, and they're working with computer vision now, so you can actually just use your hands to interact with objects. And what I really am excited for is a keyboard that works well. I'd love to be able to go into a VR device and actually type accurately on a keyboard. In order to do that, you really need to precisely see where fingers are versus where a virtual key is. and be able to kind of press the button. So you would use something probably like instant segmentation for that, seeing where a hand is, specifically fingers, and then where they land on a virtual keyboard. Feature point clustering. So this is common for facial applications as well as like pose estimation, and including hand poses too. So you can actually label hands with feature data points, and here you can see it's looking at bodies, and then it actually changes the classification here from the previous yoga pose to this one. Image captioning, so a little less common, but you can do really cool stuff combining like convolutional neural networks with other types of things like recurrent neural networks, probably transformers now. And you can actually kind of understand the context of an image a bit more, where instead of just returning, you know, kite and girl and beach, it actually understands that like a girl would be on the beach and probably flying the kite. Generative deep learning. This is a field I'm really interested in. I love generative stuff. It's really fun. I built some really cool stuff with that, including this research project. You can read on my colleague at the time, his website there, where we are building a GAN to generate original architecture designs. And this is just kind of meant to be simple 2D drawings that he would start with, and they'd have people, you know, do a whole bunch of them every day. And instead we said, hey, we could train a GAN to do this probably and take inspiration from famous architects, feed it the data, and then generate original kind of designs. And so you can actually look at the link if you want to see more of that. But this picture here, this is actually in between, before it got to any really good looking images. It just was generating random stuff like this, but I thought it looked like really cool art. So I wanted to share that. You can read more about GANs here too. But they're really fun. If you're interested in something like generating art or original designs, I've even seen people use it to generate music. It's really fun. And now maybe you could make it a NFT and then sell it. Potentially, I've seen a lot of people doing things like that. So choosing a model, there could be many use cases for different models and ways to tie them together. But when you're getting started, just think about what is the problem you're solving and what is the outcome you're looking for. So here's a little demo where this mouse is interacting with a piece of food, and when he's touching it or it's near his head, you know, it's classifying it as feeding, and then when he walks away, since it's not feeding. So you can kind of tie things together in different ways. So you just think about what do you want to do? What is the outcome? Do you need instant segmentation? Do you just need object detection? Is classification good enough? And then start from there. Any questions in the chat? Feel free to put them in. Someone said it went out on a limb to say tropical for the text prediction. You know, that's a good point. Maybe it's trained on, you know, like actually, well, maybe not from this view, but like Florida beaches look a lot different than California or most of California beaches, or sorry, Northwest beaches. I shouldn't say I'm familiar with all of California. But like the beaches here in Seattle look different, and in Oregon, where I'm originally from, a lot of times it's like darker and cliffs and stuff. But yeah, this from this image, just looking at the ocean, it probably couldn't really tell. Maybe it did just go out on a limb. Maybe the training data set was biased with like darker images in the Pacific Northwest because the training data was always in winter or something. But yeah, any questions so far from anyone? What out of all those things, what was the most exciting? Like if there was going to be another workshop on it, what would you want to attend? Auto captioning, cool. Generative adversarial networks, yeah, the GANs are awesome. I have been thinking about doing a GAN workshop at some point, because I think that would be really fun, and it'd be really cool for you to like, you know, get all these images of something, and then you create your own kind of like generated art or picture or something. It would be really fun. Someone said they like autonomous vehicles a lot. Awesome. You can actually use a lot of the things like instant segmentation or object detection potentially for something like a autonomous vehicle. I think you were the same one who did the lane line detection, right? Someone said instant segmentation is really visually engaging. So I actually will talk about, like we're going to build the object detector. but it's actually very similar to building instance segmentation. I'll actually talk about labeling for instance segmentation because it's kind of similar. And then also when we get to the code portion, I'll talk about how you could change out essentially one or two lines of code to change it to be instance segmentation. So when you go build your own project after this, or hopefully you will, you could do an instance segmentation model. But I do plan on doing a workshop soon, specifically around segmentation and maybe using a different Python package just to make it a little bit more variety. Someone said how to deal with highly overlapping regions and different features. Pretty cool. Someone said, are there collaborative public interest in projects to label data sets? Mechanical Turk. Collaborative. I'm not sure what you mean by collaborative public projects. Like, do you mean like volunteers that would label data for you? I'm not quite sure. That's kind of cool. But yeah, there are things like Mechanical Turk. I have seen, so I haven't seen like a collective for just general data labeling that might be out there. Someone should put it in the chat if they do know. But I have seen companies with followers like get volunteers to label data. Like I believe I've seen Comma AI, they do like an autopilot thing for your car. And I'm pretty sure you can actually get data from them and like help label it to improve their product. But I haven't seen just like one collective. But a lot of times probably also because it takes a long time sometimes, and people get paid to do it. So there's also a lot of companies that do managed labeling. So if you don't want to do managed labeling, like we have that as a service. I'm sure there's a ton of other ones. I think Greg mentioned he got one or something this week. There's definitely a lot of companies that can do labeling for you as well. Cool. I'm gonna keep going. So object detection in a gist. I'll link to this much more detailed article so you can read way more about it. And there's different object detection kind of architectures you can use. But essentially what's happening is you give it an image and it has a trained classifier and knows how to kind of look for objects. It kind of scans around. It'll find like propose several regions where it thinks an object might be, and then kind of runs the model and makes some predictions and combines all the output it got and makes a prediction of where the object would be. So again, that article goes into way more detail. So popular object detection methods, you have a single shot multi-box detector, or abbreviated to SSD. Object detection, or it does object detection, and it's very fast. It's typically pretty lightweight. So if you're going to do something on a very small edge device, this might be a good option. Then you have YOLO, or you only look once. It does object detection and it does it pretty fast. I know there's a new version, so I actually don't remember what the current benchmark is versus SSD, but those are kind of the two you can look at for object detection that maybe you can deploy on some smaller devices. I often see SSD, single shot multi-box detection, be kind of the choice for doing something in like a Jetson Nano or Raspberry Pi, at least for hobby projects. You sacrifice typically some accuracy every time something gets faster. If mask Arsenin or faster mask Arsenin can do object detection, instant segmentation. It tends to have higher accuracy, but it's slower. And then today we are going to train on a Python library called Detectron 2. It's actually a fork of kind of the faster mask Arsenin. And then it's maintained by Facebook. They also maintain PyTorch, which we'll talk about a little bit later, but PyTorch is one of the most popular deep learning or machine learning frameworks. And this is kind of another layer to it that makes it really easy to train a whole bunch of different models. So here's a little preview of some of the stuff I can do. And this is good to think about. So if you have a use case, like actually some people were talking about using it for animation and graphics. And oh, I think I have something where it plays videos double speed by default. I'm usually pretty impatient. So here you can see it's doing object detection, right? Drawing these rectangles around specific objects. Here it's doing that pose estimation. We saw a demo before. And then here it's doing something called dense pose. And so this actually takes input of like where their body positions are and draws automatically a 3D representation of how their body's posed. And so this is really cool. I've seen people do similar things for generating things like graphics for computer vision, for video games, and even some motion picture stuff. I'm not sure You probably know way more than I do about the current state of like how it's used in motion picture. But I have had some people say they're working on some interesting things at these types of workshops that use kind of like the instant segmentation or feature points and kind of automatically generating characters. And if you've ever done anything like rotoscoping before in like graphics, you'll actually see like labeling polygons is kind of similar to it. And here it's doing the instant segmentation. So it's drawing, not just drawing a square around it. It's actually saying like, I think this exact thing is the pixel. I think this is a cup. It's got the person in there. And this is using a pre-trained model that you can actually get access to. So if you just want to run this, it might work well, depending on what your data set is. And then this is doing a version of that, but it actually draws every single pixel in the video. So it actually includes all the background and actually does a good job here. So it's like wall, microwave. It actually knows this is cabinets, and then this is a wall tile even. So it has a lot of really cool features, and we're going to train something today using our data set. Just to briefly mention, so the full computer vision lifecycle, if you are starting in an industry, you could think about device management, so managing kind of the edge computing resources and sensors like cameras, data collection, managing data from sensors, or in this case, cameras, or you could do web scraping, right? But typically you have to collect data in some way. And then you have the data annotation or labeling, which is what we're going to do today. The machine learning side of things, model training, and selection, and that's what we're going to do today too. And then after that, you have deployment, which is like a whole nother thing. And then often you kind of want to repeat this cycle over and over, depending on what you're doing. But the example is I always use like the Amazon Go example, where if you trained your data set to detect people in the winter and everyone is wearing like big hats or big coats, and then you're trying to do predictions on if this is a person or not in the summer, and everyone is wearing shorts and tank tops and shorter hair or something, it probably won't predict at as high of accuracy, because the kind of data in the real world has shifted from what it was trained on. So a lot of times you'll set up something called continuous machine learning, and you kind of keep getting that data. And I'm guessing Amazon Go does this. I don't work there. You keep collecting that data and then keep retraining your model, so it just improves or stays good over time. We're building that out in one kind of single platform right now that you can actually get a preview on if you want to contact us. Right now, it requires a little bit of integration, but eventually, like we're rolling features out, which is going to be really exciting. But if you're interested in that or model building or anything like that, feel free to let me know. And then, all right, so we are going to get into image labeling, or the data annotation side. Is everyone ready? Just again, you can sign up here. Copy this in chat. And then you don't need to do this. So this is just if you want to follow along right now, you actually don't need to follow this part along because I'm just going to show you examples, and then you'll know how to do it for your own data set. Because the coolest thing is you go through this, especially if you've never done computer vision before, and then you understand how to label a data set, and then you do it on your own data set, and then you bring it into the code, which I'll talk about, and then train your own model. But if you do want to follow along with any examples, I just have them in there. Or you can feel free to upload a local image from your computer and try labeling it, or just playing around with labeling it. So I'm going to open up my data labeler. It looks like this. Yours will probably be empty if you didn't sign up before or try anything. So I want to create a new data set. And I'm just going to show various examples, kind of all the things I think you might run into when creating one. So I'm just going to call this a demo data set. You want to give it a much more meaningful name, like geese object detection or whatever you're labeling for. Save and continue. I'll hit source. I'm going to add a source. I'm going to upload just local images here just to give the examples, but you can connect to something like Amazon S3 or Google Cloud Storage. So most of the enterprise people probably are using something like this. At least in my experience, a lot of people are using like Amazon S3 or Google Cloud Storage to store your data at, so you can easily kind of bring it in here. Choose files. I'm just going to choose these examples. Again, I did link to them if you want to download them. Don't feel pressured to. I'm just going to quickly go through kind of all the labeling steps. So here they're uploading. I think some of them kind of big images. I didn't resize or compress them here, so it might take a second. There we go. I'm just going to scroll up. I'm going to go to label definitions. So before you get to this point, this is where you kind of want to know, are you doing object detection, instance segmentation? What is it that you're trying to label for? You should probably have that defined before you get to this point. So I'm going to make a few examples just to show. So I'm going to do a goose, and this I'm going to leave as a rectangle. This is the kind of how we label by default for object detection. You can also use polygons for it, but I'm going to leave it as a rectangle. And then I'm going to do a goose example as a polygon just to show how I would do it as a polygon instead of a rectangle. And then I'm going to do an example of a car, labeling some cars. I'm going to do a polygon there. A lot of the work I do, I end up using polygons because you could do the instance segmentation, but also even if you don't need the precision of like the pixels, a lot of times using instance segmentation models and polygon datasets can make a more accurate model too. So a lot of times I'm just doing polygons, even though they can take a little bit longer, though with some really cool features, they actually don't take as much time. Do a cup, polygon, and then I'll have an example of a PCB, printed circuit board, just like kind of similar to some of the problems I started solving when I got into computer vision. And PCB damage. So I'm just going to run through this real quick. It won't be that long. We're not actually going to label hundreds of images or anything like that right here. That would be a much longer workshop. So you can change this color. This is really just for you as the labeler. If you know the geese are all on like a bright green background, you probably want to have a label color that will stick out from that just so you can see it more clearly. And then I'll actually come back to this. We have this auto label configuration. As you could probably guess, it can automatically label your data or some of it. So I'll come back to this in a little bit. We also have a instruction option. I'm not going to put anything here, but if you're working with a team, or if you're even working on a more complex data set, it's really helpful to have instructions available as you're labeling. So you could think of, like, if I'm labeling tumors or something for some healthcare computer vision application, I'm not an expert. I would need a doctor to tell me what is something I should label and what is something I shouldn't label. So you can actually include like detailed written instructions here, or embed images as well as examples of saying like, this is a good label versus a bad label. So I'm gonna hit start labeling. And we have our geese. So now this just uploaded. And for labeling our data set just for generic object detection, what we want to do is select our rectangle, label. And you would just kind of label like this. So 1, 2. One important thing to note is that you want to get every instance of the object that's in your image. So for example, if I had a geese right here in the front or a goose right here in the front, and I didn't label it, our model would have a really hard time understanding what we're looking for, because it would look at these labels and be like, okay, cool, you're trying to pick up on all these features. I think I got it. And then when it's learning and adjusting its weights, it would make a prediction on this goose, but it wouldn't have a ground truth label. And it would say, oh, that's not labeled as a goose. So it would have a hard time understanding what you're looking for. One exception to that is if a goose is like really far in the background and you don't really care if it's a text at that size or something, maybe you don't label it and you only want to do detections when it's like pretty close. But most of the time you want to label every instance in your image. So I'm going to hit submit here, and then we have another goose image here. And what I would do again is I would just draw a rectangle. So this is kind of the regular way of labeling for object detection again, right? Like you want to get all the geese. And you typically want the box to be as tight around the object as possible. In our case, we're just building a little hobby thing. Maybe it's okay, but you can come in, click on it, and actually like bring it in tighter if you want to. So it's easy to adjust all these things as well. So just as an FYI here, it shows the pending default, the pending images by default, but you can go back and look at all images or submitted ones if you want to do QA on it. I'm going to go back to all images because I want to come back and, oops, go back to all images. And I'm going to delete these images or these labels real quick. So to do this much faster, I could enable the auto label feature. And there isn't actually a goose class, but there is a bird class. So there's 81 classes in here. So it's like people, boat, cars, and stuff like that. I'm going to type in bird though. select bird, hit OK, and then boom, it automatically applied the labels to it because it detected birds and knew where to draw around them. So I'm going to hit submit again, and it'll go to the next frame, and then boom, automatically applied the labels to it. So that makes it way faster for labeling. It's kind of like you're going through and actually just QAing, making sure that your auto label functionality is actually doing a good job. Now, real quick, let me go back to this image again. Just to show a polygon example. So if someone mentioned like they want to do the instant segmentation, which I would totally encourage. It's super awesome. We'll select this goose polygon. So doing a polygon is essentially just drawing around the object. And you want to be as tightly around it as possible without actually going into it. So I'm going to do a terrible job here. So I don't want to take up too much time. This is something you get really fast at if you do a lot of it. So you can see I'm doing a pretty bad job here, but it's still like even doing it pretty bad is taking me quite a bit of time. So that takes way faster, or takes way longer to label than the boxes for object detection. So a lot of times people will be like, well, I don't want to do polygons, especially on a personal project if you're not hiring a team to do it for you, because it takes a lot longer. So one cool thing to help with that is this feature called Smart Poly. It does smart polygon selection. So you enable it by clicking this button, click on the label again. And then what you do is you draw around the object, just like you did for object detection labeling with the rectangles. And then just click, and then boom, it snaps polygons to it. So it's almost about the same speed as doing the rectangles now. So this makes it so much faster, and it makes me way happier when I have to label something using polygons. I'm going to do this example here. And oh, so it's funny because it actually worked pretty good there. Sometimes it'll mess up because if there's a, like my eye even sees it's kind of hard to see where the goose and the sidewalk starts. So actually see, I think here, technically it's missing part of the goose. It's even hard for me to tell looking at it. So if it does mess up a little bit though, like this, it's nice because if you're like 80% of the way there, 90% of the way there, you can just come in, click on this polygon, and then adjust it. So even if you have to come in and do a couple adjustments, it still usually speeds up things a lot. So you can see there the white, even my eye again, kind of hard to see that. And it's something when you're just using the smart polygon selection and not the auto label, it's actually a model that generalizes. So it doesn't know to look for exactly a bird. All right, so moving on, just another example. Let's label these cars real quick, and then this will be over soon, the labeling, and I'll catch up on the chat. So let's select this car one. Let's so let's not do the smart poly or anything right here. Let's actually just do auto label because I know there's a car class. So I hit car and then hit OK, and it should automatically label polygon. It did. Again, if it did mess up at all, you could just go in and tweak it, and then you just hit submit, and it'll go and see it's detecting a car again, and then more cars will come in. You can see it's doing it. So this is so much faster than manually drawing polygons around. It's something I was not a fan of doing, and now when like this works super well, it's awesome. It saves so much time. We'll see here another car is going to come in. And funny enough, right, it detected here, but it actually, for some reason, didn't detect this as a car. Models aren't always perfect. If you could build something that could perfectly classify everything all the time and draw a label around it, then there wouldn't be a need for data annotation tools. So you want to click through, QA it, make sure it's actually doing everything correctly. In this case, right, we'll just click our label, and we can actually enable Smart Poly, and we'll just draw a little box around it and get that label in. Then boom, snaps to it, and then hit submit again. And it detects it when it's that size. For some reason, the model doesn't at the beginning there. So this is using like a generic object detector model. I'll just keep going. So this is, oops, I didn't need to do it. That's okay. So here, now we're on a different set of images. So let's go ahead and take this cup one. We're going to use that smart polygon again. It's a little bit more of a complex shape. I like if you're doing just a square shape, maybe you just draw a square polygon around it. And boom, snaps to it. And so one thing is sometimes if you're doing like a pretty big rectangle like this and you get too much of the shadow in it, occasionally it could mess up a little bit and get a little bit of the shadow. Here wasn't exactly perfect, so I'm just gonna draw that down over there. And then what we're gonna do here is actually pretty cool. So we're going to enable something called track forward. And this is for if you ingest frames from a video and you want to track a labeled object from one frame to the next frame. So this actually does object tracking from a label and then tries to find in the next frame even at a different position, automatically apply the label again. So we'll just hit submit here. Again, you enable things like that just in this little drop down, and smart poly is there. There's also something called copy forward. So if objects aren't moving, or if just track forward doesn't work well on your data set, you can use copy forward and it'll actually just copy the labels to the frame and then you move them around to your data. But we're going to use track forward. We're going to hit submit. And new frame. Slightly different view, right? Like it's meant for something like this where things are, moving across the screen or something like that. You'd label it once and then just automatically get those labels applied per frame. So again, like anything you can see, all these features are really about just like time saving, because labeling isn't always fun. It might be fun at first, but after you do like 500 images, you might get kind of bored of it. And then here, I should have disabled that. Or yeah, like not done on this frame. And then for the PCB, right, just you can still do all the manual labeling too. So if you were doing this, you could draw a square. I'm doing a terrible job under pressure of drawing this square. But I would do something like this. And then I don't think I accidentally saved my other label, but then I would have a label for damage, like PCB damage, and then if I'm trying to train a model to detect like a PCB and then scratches, you can label this as something. Again, I don't think I saved the other label, so this would be like scratches or PCB damage, then feed that into a model. And you could be like, hey, when you detect a PCB, then also look for scratches class. So once you have your data set all labeled, you hit the submit button, you just go to this review tab, or it'll automatically take you there if your data set's done. And then from here, you can export your data set into a whole bunch of different formats, all the common ones, or most of the common ones for computer vision. You also have some QA stuff. So again, a lot of people we work with actually have like teams, and you will actually want someone to go through and QA to make sure people labeled it correctly, right? Like I was saying, if you're labeling a complex tumor or something, you probably don't want to train it if it's bad data. So you can go back and review. You can go back to the labeler here. You can actually go to these submitted ones and manually go and approve them. But we're not going to do that. And I usually don't do that for my kind of hobby type data sets. That's more for like industry applications. So I'd go to this review tab, I'd hit export data set. And then you just want to scroll down though, and make sure you check this just submitted annotations, because otherwise it'll only export approved ones, which again is important in most industry cases, but not here for our hobby projects. So you just want to get the submitted ones. We didn't manually go through and QA them. And then you select what type you want to export it as. So we have like a generic JSON format that can do kind of anything in our application. We have create ML, which is Apple's version to do like classification or object detector. We have Coca, which is the one I use actually quite a bit outside of the Sense JSON, and I see maybe the most places. Again, these are just ways of formatting what we just did, like a collection of our images and then tying those labels back to those images so our model can read them in. And then we have Yellow and Pascal VOC. So you might see any of these come up if you're following like a tutorial or something, or your framework has a way to automatically read these in. Sometimes it's nice to just export to Cocoa because like Detectron 2 or TensorFlow, they I think all have functions to automatically read in a Cocoa data set. So you don't have to build a custom data loader or anything most of the time. And then you have some other options like the train test validation split. I'll actually talk more about that when we get to the code and read in these images. But most deep learning, machine learning applications, you do something called a train test validation split. Just it's training data and data for validation as you're training. and then testing data once you think you have a good model. So just hit export now to get my Cocoa data set. And I'll say export completed. And you'll actually receive an email with a download link. And then also you'll get a notification here. I've noticed with a push notification, sometimes it takes like a second or two to show up. So if you are impatient, like I am during this workshop, you can just hit refresh, and I think it should be there. Yep, got this, and I'll hit download. And we'll get a little project folder. I'll just open this up just to show you what it looks like. So we then have a image folder here with all of our images. And then we also have a test, train, and validation JSON file. So if we open this up, it's going to look very ugly. Don't feel intimidated by it. You don't really need to know what's happening here. This is just the format that our model is going to be looking for. So you can see it looks really, really crazy. I don't have an extension or anything in VS Code to look at this in a better way. These are just coordinates of our labels though. So like polygons has a lot more. Bounding boxes will be 4, saying that, here are the points for the rectangles. And then they point to an ID of an image. So the Python code we use will read an image in, read in this data, and it'll be cool. I'm going to exit out of this, and let me go back to the slides real quick. And then I'll read, I see some chat messages, so I'm going to catch up on chat. But right after this, we'll get into training our own model with Python. So let me just catch up. And if you have any questions, put them in the chat, or just anything you want to say, let me know. And also, I apologize, because I see there's quite a bit. So if I don't get to one, I'm not purposely ignoring it. I just might not be able to get to every single question right now. I see someone's asking me to potentially do another talk somewhere. Let me take a picture of the email you shared. And then also, if you want to connect with me on LinkedIn or the Slack channel, that's a good way to follow up with me. Someone's saying auto polygon that can be fixed is nice. Yeah, so I hope that you could always fix them, because, with any tool like this, like I'd love to say it's always going to be perfect all the time. But in all honesty, right, like I've never seen a tool that's perfect, because computer vision just isn't perfect. It can be really good, but it's going to make mistakes sometimes. And when you're labeling data, you should be able to correct any of those mistakes. And again, like I was saying, if it gets you like 80 or 90% of the way there, it's awesome, because it has drastically sped up my labeling time for almost anything I do. Oh, and I should also note, so the auto label feature, right? Like we're pulling from 81 common classes that you can choose. But we have a feature coming out soon. It's not out yet. You'll actually be able to train a model with the data set that you're labeling, and then feed that model back into here, and then tie it to auto label. So if you have a more complex data set, or for whatever reason, like this one just isn't generalizing well to your data, you'll be able to label some images, train a model that hopefully will get you pretty accurate results, and then have it label a lot of the data for you. So that's coming super soon, I believe. And it's awesome. Like it's something I've always wanted to have in an easy interface, where I can just, like, as I'm labeling, feed it to a model, train it, and then have it label the images for me. It's like a no-brainer. Like, why would I not want to do that? Let me catch up a little bit. And then again, if you have any other questions about labeling or anything else, let me know, or just the tool. And then we're going to get into the Python section. Someone said, using ImageNet or Cocoa existing models, can you offer a semi-supervised learning approach to more easily label common classes? So that's kind of what we're doing here, right? So we have a pre-trained model, and like we selected bird, and it labeled all the birds. I think you're right. I think there's a cup class in there, right? Sorry, I haven't memorized all the 81 classes in the data set. So let's go and try this out real quick. I'll just select, oh, there is a cup. Is there a mug, or is it just cup? Okay, it's just cup. And let's see, oh, did I not type that? Cup. Okay. And And ta-da! Yeah, so this is doing that semi-supervised thing. The only problem is a lot of data set is really complex and you won't have a model that generalizes over everything. So then being able to train your own model on your own data set and have this do this exact same thing for you, but with your own model, is going to be really awesome. Someone said, can we use smart poly after auto label? Yeah, so in the car example, I think I even showed, right, there was a frame that it missed one of the cars, and I used smart poly to label that frame instead, because it did miss, I think it was this one. It didn't get the car when it first came in. So what I did was I did auto label, and then I went and just did this car instead myself. And I should note, like, you want to be pretty close around the object, right? Like if I do a giant square, it'll probably mess up. So you want to be like there. I think it just drew a square. Didn't know what we were looking for. So you want to be as close as possible, just like you were accurately labeling for object detection. And it does a pretty good job on a lot of data sets. Like there's been times where I've been surprised that it's like working so well. But again, it might not be perfect, right? Like you saw in the goose. So then you go in and you can move all these little nodes around. Also, if you want to delete a node, like if it added too many, you can select it, hit backspace or the delete key, and it'll get rid of it. If you want to add a node, you can hit these kind of grayed out ones. And so you can really get the shape you want here, which is pretty cool. Oh, someone said, if there are two geese, one behind the other, would you draw one box or two? I would try to draw two geese. So a lot of times they might be overlapping in some of the data set that were. You want to have two boxes around most of the body of the geese. Even if it has part of the second goose in the box, it should pick up on those features. It can be hard on a data set where there's like a lot of stuff going on. It's a good question. All right, so I'm going to go back in. Let me share a link with you for the coding, and I'll still try to get to any other questions coming in, but I do want to keep moving just so we can finish on time, we're making good time, so we should be good. Just real quick, so some popular Python libraries used in computer vision. There are many, but here's a few that you should know about just getting started. So PyTorch, I already mentioned this. It's a library from Facebook for machine learning, really popular in deep learning and computer vision. And Detectron 2, the thing we're going to use today, is kind of just another layer to that makes it a little bit easier to train some of the more state-of-the-art models. And then we have TensorFlow and Keras. That's a library from Google for machine learning, again, popular in deep learning and computer vision. That's actually, these are kind of like interchangeable, where people will be like, are you using TensorFlow or PyTorch? Those are kind of the two common ones. And Keras is actually now part of officially TensorFlow 2. It used to be kind of another layer to TensorFlow that made it easier to write it. So usually people will say TensorFlow and Keras, and those are actually a little bit interchangeable. These ones would be like, instead of using TensorFlow, you would use PyTorch. You have OpenCV. People have already talked about using this in the chat. It's an awesome library for image processing and computer vision. It's also really good for like bringing in images, doing processing to them before you're doing anything like feeding it to your machine learning model. Pillow is an image processing library. I actually really like it for writing out kind of visualizations of models. And then you have NumPy, which is really great at processing multi-dimensional arrays, which is actually what an image becomes when you load it in to Python. We can actually look at one of those. And again, this isn't everything. These are just the kind of a few that you're going to see today. And that you'll probably hear about. So let's build an object detector. I'm going to share this link out in the chat. And if you want to follow along, open it up. Should take you to a Colab notebook. And you should get something like this. And once you're here, usually takes a minute for everyone to do this, go to File and hit Save a Copy in Drive. So go to File, Save a Copy in Drive once that loads for you. And it might take a minute to do that. So I'll say creating copy, and then if it might not be quite as fast as it was for me there. So it should take a minute, and then this will load. And you should have your own copy here. And once you have your own copy, you can do whatever you want to this. So feel free to change code around. If you ever break it too much, just go back to that link I posted in the chat. So you could bookmark it and always come back to it. So don't feel like you're going to mess anything up too much here. And if you've never used Google Colab, it's essentially Google's way of hosting a Jupyter notebook, which is a really popular tool in data science or machine learning. If you haven't used one yet and you're going down the path of being a data scientist or something, chances are you will use one at some point. It's a really cool way of writing code and documentation and outputting visuals all in one place. So you can actually double click here, and this will bring you in this edit mode here where you can actually edit this text. To get out of it, you can hit Shift Enter. And then something I want to show you. So if you're creating your own Google Colab, you don't need to do this at all right now because you made a copy from mine. But you can go to Runtime, change runtime type, and select a GPU. And this will actually give you GPU access. I think on the free version, it's something like 12 hours. It's actually quite a bit. And so it's awesome because a lot of times a barrier for people to get into computer vision or deep learning is they don't have a GPU that they can run deep learning models on, because pretty much they need one to train on. Otherwise, it's going to take a long time. And it should, a lot of times you'll want one to even kind of run the predictions on. So it's really cool. This gives you access to a GPU and a TPU, which is kind of Google's kind of version of a GPU for tensor processing. So you don't need to change anything here, but I did want to show that to you. So if you're building your own from scratch, you can get GPU for free, which is awesome. And with Colab, it also comes with a lot of computer science or data science libraries pre-installed. So like it already has TensorFlow, PyTorch, things like that automatically installed here. And then you can also still install things that aren't there, but it's kind of really cool to just kind of get set up in here. It does disconnect sometimes. So like if you're running something for 12 hours or more, it'll probably disconnect. So that's kind of the downside. It's a really cool free thing to get started with. But if you're doing production level stuff, chances are you'll want a VM or something that could be up much longer. All right, so let's go ahead and get going. Here is just a code cell right here. And you can hit run this little play on it. And once this goes, so it can take a minute for the first code cell to run. It'll say connecting up here. Once you're good, then everything should run way faster. And these are code cells. So let's actually run this one. This actually has some code in it. So it says hello world. If you've never done Python before, congratulations, you just did your first Python programming, and you can now add it to your LinkedIn. So you did hello world in Python, where you're just typing print, quotation marks, that's a string, and then you're printing out that text here. So just making sure in the chat, did that work for someone? Just want to make sure there was no issues. Made a copy, and then you were able to run this hello world little script. Someone said, yep, awesome. Did anyone have any issues? Just double checking. Sometimes if you reword things, the reverse, other people will answer. Or is it working for everyone? Give you a minute just to make sure before we get going. All right, people are saying it's working. Cool. Also, just want to note, so it's not just a hosted Jupyter notebook. It actually gives you kind of a whole Ubuntu instance for this notebook. So you can actually run terminal commands in there. Again, if you're not familiar with Ubuntu, Linux, or Bash or anything like that, don't worry, we're not going to be doing a ton of this, but I just want to mention it. So if you do ls in your Linux terminal, in this case, you put the little exclamation mark at the beginning, that'll run the bash command. ls lists all the files or folders in this directory. So if we run this here, there's a folder called sample data that comes pre-installed, so you can easily use some sample data sets to do data sciencey things. So we might do this once in a while just to make sure, okay, cool, the data set downloaded or anything. And it's also really cool because you can run things like pip install, which is a way of installing libraries in Python. So we're just going to run these code cells. Make sure you do them all in sequence. So most of the time, if someone has some sort of error during their workshop, they accidentally skipped a code cell. So you can hit this play button here. Or once it's highlighted, you can hit Shift Enter, and that's usually what I do. So if you don't see me hitting this play button, it's me doing Shift Enter. So let's go ahead and install PyTorch 1.8. And it actually should be pre-installed, but the thing about Google Colab is it actually automatically updates to current versions of things all the time. And if you don't have a code cell like this in here, if you went and got this notebook in a couple months from now, it might have a new version by default, and then everything would break. So I'm just running this just to make sure, but most likely it'll be like, oh, that's actually already installed. Unless if Google actually just updated this to a new version of PyTorch that I'm not aware of. Let's see. So it is downloading it. Just take a minute. And you can also run. So while a code cell is running, you can actually go to the next cell if you want. And then it won't execute until the first one is run. So it's pretty common. You might be like, run this, and then I know I'm going to run this afterwards. So I'm just going to do those and wait for it. I should have probably just done a if statement real quick to see if it's PyTorch 1.8 before trying to download it. But it should finish up soon. Oh, so requirements already satisfied, I think, for most of these, and we should be good to go. If you get any errors like this, don't worry about it. We're not using Torch text or anything, so don't worry if you get something like that pops up. And this is taking longer than normal, so hopefully this works. Doing things live is always fun, everyone. If you ever want to have a thrill, you should program live in front of people. All right, I think it's going. Oh, I guess it is. Oh, because it's 1.8.1 now. So they did update this since last time I think I ran this notebook. So this is exactly why I have this in there. But sorry, it does take an extra minute if it did change versions. Okay, so now that ran for me. Hopefully it ran for you as well, or it's almost done. And then here we're installing a couple more things, PyYAML, PyCoco tools, things we need to use. And then if you've never used Python, to import libraries into your project, so you download them to actually bring them into like your code file, you use an import statement like this, and then you say the thing you want to import. So we had downloaded PyTorch, or Torch as it's just called here, and we're importing it in. So now we can use it in our project, and then I run the cell and it just prints out the current Torch version. And then I think I did this a couple times for troubleshooting once there, but you can see it is 1.8.0 now. And CUDA is the way of deep learning frameworks interacting with a GPU. So sometimes you'll need to mess around with different CUDA installs for different versions as well. And then we're going to install Detectron 2, so this might take a minute as well. And then once we do this, I think most of the downloady stuff is done, so we can go much faster. But here we're pip installing Detectron 2, and this is for Torch 1.8. And most of the requirements are already satisfied, and I think it's done. And then we're just going to install, I think this is the version of Pillow we need. Maybe it's updated now, but we'll run it just in case. Again, don't worry about these warnings. It's actually should be fine here. And then here we're going to import the stuff we need to actually train our model. So we're importing Detectron 2. We're importing other various things from it, like the logger, model zoo, which I'll talk about. But that's essentially just all the different models that you can grab from and train on. Some other things, and then we use NumPy as NP. So if you've never used Python before, you do import NumPy, and then you do this thing where you say as NP, and then we can just call it saying NP dot whatever instead of typing out all of NumPy. And then we're importing a few other libraries as well, and we'll see as we use them. So go ahead and run this. I almost forgot. Would throw an error later. And if that all imported fine, we should be good to go for pretty much everything else. And then this just has links for labeling your data set. So if you do share this with someone, they can see how to label it, but we already did this, so don't worry about it. We're going to download a data set here. I'm going to talk about how there's a couple ways of getting your data set in. In this case, for the workshop, it's much easier if I just have it in a Git repository. So I just have our data set where there's like 143 images of geese. They're all labeled, it includes the JSON files at that repo. So feel free, you can go and take this data set if you want to play around with it some other time. But we're going to download it, and I do that ls command, that bash Linux command, and it's looking in the folder, seeing now there's an image folder and all the JSON files. And then there's all these images here of geese that we can now use. So importing a data set into Python, or in this case, really specifically to Detectron 2. So we're going to use a function from it called register Coco instances. And that's when I was saying how we export it to Coco because a lot of the deep learning frameworks have a function that can automatically read in that format of data, which makes it easier for us. So we're going to go ahead and do that. So you can see it says register Coco instance. We give it a name. This one's called my dataset train. This is kind of just from their documentation, but you could change this variable to anything you want for your dataset. Then we point it to the JSON file. So if we actually, you might not have this open, so you can hit this little folder thing right here. And you'll see this is a little folder explorer now of our Ubuntu instance. So we could actually go into this Goose object detection dataset folder and drill down, and we can see now there's an image folder here with all the images. And then we have those JSON files. And so this is actually directly pointing to the train file, which is what the data our neural network is going to look at to learn the features of a geese. And if you want to change this out, these are just the paths you need to change to your data set. And then, so this second one, this is looking at the image. So this first one looks at the JSON file, then this looks at the folder where the images are. But a very important thing to note is it's actually the one layer above this IMG folder. And the reason is the path in that train.json is actually looking in the IMG folder, the image folder, for the images that are associated with the labels. So you would grab this level of folder and put it here. So just to show you real quick how you could do that on your own data set, there's a couple different ways. One way is you could literally get your data set you downloaded and select it, and then click and drag it and just upload it directly to the instance here. It would just add all the stuff right in there. And then once it's in here, you can right click on it very easily. So here I could just right click, hit copy path, change out this JSON one. In this case, it's going to be the same, but I'm just going to paste it in. So it's really easy visually. You can navigate around, grab your data sets, and then paste it in. And then another way, and I recommend doing this if you think you're going to come back to this model several times, because if you upload something just directly in your instance here, as soon as it resets, or like if you were to go away and come back, it wouldn't be uploaded anymore. So if it's a big data set, it's really annoying to upload. You don't want to do it every time. What I recommend doing is you can click this button. I think it might generate a code cell. You don't have to run anything extra right now, but this allows you to mount to your Google Drive. For me, I think it'll automatically do it because it probably trusts my own Colab. Let's see if it will go out to Google Drive. So now I have this Drive folder. For you, it might generate a little code cell, and you can run it and do some like validation thing. Like I think you have to go get a code from somewhere, paste it in. You don't need to do it right now, but I just want to show it because this is how I would do it. Create a folder in your Google Drive for data sets. And then every time you need to come back, this will all be kind of in the same place. So you could just have like, I had a dog data set here. I would just copy this train.json, paste it here. And then every time I would open up this Colab, it would still be looking in the same place and be able to grab those images every time. So it seems a little complicated just talking about it, but once you do it once, it's actually not hard at all. So you just go to your Google Drive, make a folder for data sets or whatever, however you want to organize it, and then you can mount from here. Once you do it once, you'll be like, oh, that's actually really not too bad. And you'll be able to import your own data sets very easily. But if you do have any other questions about it in the future, feel free to ping me on the Slack or LinkedIn. So I'm going to run this. This is going to create our train, validation, and test data sets. And we'll talk about that as we're actually training our model, because it'll take a little bit of time and I can dive deeper into it. And then here, it is always a great idea to, once you load in your data, to print out a few samples of it. So here, this took 3 random samples from the Goose data set. And if you run this again, it'll actually just take 3 other random ones. And there's actually a reason to why these geese are photoshopped in some of the images. I think I linked to it at the end of this notebook, but this is actually about synthetic data. So someone brought up synthetic data before. I did a talk on synthetic data and was actually creating it in a 2D space with existing images. But that's why they're photoshopped. And I could talk more about that later if we have time. But essentially what this is doing is reading in our training data set, getting some stuff from it, some metadata, say like the classes, like that's how it knows it's a goose in there. So it's reading some metadata from our labels. And really this is just saying, for our sample size, get 3. And then this is a way of reading it into OpenCV. We're using the visualizer function from Detectron 2. And this is actually just kind of a funky thing, but it's switching the order of the the color values for our image, like our RGB is typically what most people think of, red, green, blue. But OpenCV actually reads things in blue, green, red. I always remember that because it sounds like burger in my head. And so you actually need to switch those color channels. That's just what is going on there. And then we're printing out the image. And this is really good to do because I've actually done this in the past for like some sort of hobby project where I like swore I was reading in my data set correctly. And when I printed it out, it was like something was wrong and these rectangles weren't actually around the objects. They were just random. So it's always really good to check that your data is there and what you think it should look like. This is actually what our Cocoa labels look like now that we read it in. So we can look at this dataset dictionary object. You can see it's a very giant, just Python dictionary. And it essentially just has bounding box coordinates and then ties those bounding box coordinates to an image. And that's how it knows to look like here for a goose or not. So training a model, we're just going to run these two code cells. So I don't need to share this in the chat if you're following along, but I guess I will in case someone's not following along or they don't have the notebook open. So one thing I don't like about Detectron 2, it is awesome, but it doesn't have an easy built-in way of doing validation during training. So this Medium article I linked to kind of talks about how to do that. So I took that from there, where they just create a class here, and it's just going to be loading in our validation data set every 50 cycles. And I'll talk about why in a second, but let's go ahead and run this code cell. And let's go ahead and run this code cell, and then I'll talk about it as it's going, because this will be the longest code cell to run because it's actually training our model, which can take a little bit of time. But you'll see it actually won't take an insane amount of time, and we're going to get a really cool model from it. And that is the power of transfer learning and free GPUs. All right, so we have the three data sets. We have the training, the validation, and the test data sets. The training data set is actually what our computer vision model is looking at and learning from. So it'll say, hey, cool, like you gave me labels here. I'm going to try to extract the features and understand what you're looking for. And then I'm going to make predictions, and I'm going to be really bad at first, like at understanding what you want. But then I'm going to compare it back to those ground truth labels, make adjustments to my network, and then get better over time. So it uses the training data set for that. And then as your model is training, we'll talk about this output in a second, but essentially, as your model is training, it should pretty much always get really good at recognizing the data that you're training it with. So what you want to do is use another data set, the validation data set, as you're training to run it on data that it's not learning from to make sure that it's actually generalizing well. So it will almost always fit pretty well to the data that you're feeding it. Like you'll see that the accuracy should go up for that, but occasionally it's going to like overfit or not learn how to work on other data sets it might see in the real world. So we're going to feed it pictures of geese that it's actually not learning from. That'll give us a good clue of how good our model is learning. And if it's not doing what we want it to do, then we adjust things like these other hyperparameters, which I'll talk about in a second. But so the validation data set's kind of like for the human in the loop during the deep learning side of things. So I can see how it's doing on there. I can make adjustments to my hyperparameters or data, like bring in more data and stuff like that, or change augmentations. And then once I feel like the model is good there and I feel pretty confident, then I want to run it on a separate test data set. But the test data set is separate from the validation and training. So it never really had any direct input of the hyperparameters or the neural network. And that's why we have three data sets. So here we're setting up the Detectron 2 configuration. So it does it in this pattern. Here we're just creating a variable called CFG for config, getting this get config function. And then we're saying cfg.merge from file. And then we say modelzoo.get config file. And we have this URL here. And what you can do is I have a few other ones here. So if you did want to do instant segmentation, you could just copy this and replace this kind of like string with this, and then you could train a segmentation model if you had polygon labels. So you have some options here. You can go explore the model zoo. Let's see, the documents are up here, and then the model zoo is here. So if you did want to use a different type of model, you can go explore all the ones they have. And I believe it's this URL, one of these URLs where you can get kind of what I typed in there, but it'll be slightly different. So in this case, this is Cocoa detection. So it's doing object detection, and then it's using a faster mask CNN. And then we have this other line. This is where the transfer learning portion comes in, where I said almost all the frameworks will have kind of pre-trained weights that you can import. And that's what we're doing here. So instead of starting from 0, we're using a pre-trained neural network on the Cocoa dataset, which has like 81 classes in it. So we're not starting from 0. And then this is important. So if your dataset has more than one thing, you want to change this. So we're just doing geese today. But if we were doing geese and ducks, that would be 2. If it was geese, ducks, and boats, that would be 3. This is pointing at our training data set. So if you did change the name of that, you want to change the name here. You can also read in multiple data sets for the training data set. So if you had a new data set you brought in, you could update it here. And also it's important to always have this comma, even if you have one data set, because that makes this data type a tuple, and that's what it's expecting. This solver max iterator, this is how many cycles or epochs that your network's going to look at your data. So it's going to go through our geese 300 times and learn from it each time, make adjustments, read it, and again. Here is the learning rate. If you're new to deep learning, you don't really need to worry about this too much right now. I would definitely recommend reading more about deep learning and what a learning rate is. But sometimes you need to adjust this up or down as well. So it's one of those things you could do. And then here's some more advanced stuff you really don't need to worry about right now, but it does give you capabilities of working with like multiple GPUs and like how many images to read in, how many instances in each image to read in. Don't really need to worry about this for probably most of the stuff you would do at least on a hobby type level. This is just making our output directory. And then we have our validation data set here. And then this is saying every 50 cycles, we want to take our model, whatever state it's in, and then run it on this validation data set, data it's never seen, and see how well it does. So now we can look at our output. There's a whole bunch of stuff here. This is actually a convolutional neural network. This is kind of the structure of one if you've never seen it. I won't go too deep into it, but that's what all that crazy looking stuff is. You can see it read in our images. There's 110 images for training. There's 260 instances, so most of the images had more than one goose in it. And then our validation one, there was 37 instances to test on. So now our training, you can kind of see all this different output as you're training. Let's see where this, I believe, is the first validation output. So you can see it's returning something called AP. That's average precision. And I do have a link. I think it's a little bit later down in the book when we do the test data set one more time. But it talks about how to measure things like object detection, because it's a little bit different than just being accurate, because it's actually drawing boxes. So the average precision is like how closely drawn was it to the ground truth label we read it. So you can see it starts out 18. This seems like a pretty low number. And then you can see as it's going, you have a thing called total loss going. Well, loss should pretty much always be going down, hopefully, on your deep learning models. And then accuracy type stuff should be going up. And so this is kind of giving us output from the training data set. But what we really want to see is like this validation data set output. So you can see after just 100 cycles, because it's the second time, now it's 42 average precision. And so like the higher the number, the better. Like ideally, if you could get to 100, that'd be awesome. Probably won't. And then you get to 66 and 75, which is pretty good. Keeps going. So just every cycle, right? You can see that our network is improving at recognizing geese in this case. So it looks like we ended with 77, which might be pretty good here, at least for just how many times we trained it and the amount of data we have. So I didn't talk about it, but the data set's super important. You want to have usually way more data than like 100 images like we're having here. Probably want thousands, but it's okay to start with hundreds and see how good it is, and then keep adding data to it and making your model better over time. So if we run this next code cell, which also let me catch up on chat real quick, but oh, someone said, let me see, I'll catch up real quick. So if you're still might be training, depending on what GPU you got on Google Colab, so it's kind of random. Sometimes you get a really good one, sometimes you get a less good one. So let me know if anybody's training finished yet in the chat. And let me read a couple of questions. Someone said, in this training pipeline, are there choices for image augmentation? I believe there is in the Detectron 2, you can definitely do that, but it's not in the notebook here. But yeah. And so that data augmentation, for anyone who doesn't know, is like when it's reading in your batch of image every time. So if it's reading 32 images, it'll actually do some kind of typically randomish, or you can set it augmentation. So it will slightly like zoom in, zoom out, skew the image, rotate the image. So it can actually generalize better on data it hasn't seen. So occasionally in the workshop, some people will say that this TensorPort doesn't load, and I don't know how to get around it, but it's okay if it doesn't work. It doesn't affect the rest of the workshop. But this TensorPort gives you a chart of like how your model did, or like how it learned. So you can see our average precision is going up, and it looks like it's still going up at the end. So if we did more iterations, we might get even a more accurate model here. There's some other stuff you can explore around in, like if you wanted to see loss, again, typically should be going down as you train your model. And then you look at these charts and you can be like, oh, it looks like I can maybe train a bit more, maybe before the chart kind of plateaus out. So maybe I would want to do several more iterations and see how my model would do. All right, so now we have our trained model. And again, if you've never done deep learning or computer vision or machine learning, you just trained your first model if you've never done it, which is super awesome. So congratulations there too. If we hit this ls output, which again is just looking at our output folder, we can actually go in, see there's an output folder, and there's actually a model_final.pth, which is a PyTorch version extension for a model, the PTH. And now we can read in that model and then use it. So very similar to training, you have this config kind of setup, CFG, get config. And then this is important. This will always, this should always be the same type that you selected during training, because this is actually setting the model architecture, saying we want to use the faster mask RCNN. If you use a different one during training and we ran this, it would run an error because it wouldn't know how to read in the model. So this should always be the same as what you did for training. And then instead of loading in the pre-trained weights like we did last time for transfer learning, we're actually going to load in our trained model here. And then we're going to load in our test data set. We'll use this later to do some metrics on. And then again, however many objects were in your data set, you want to change this number to. So we're leaving it 1 for the geese or the goose, but it would be 2 if it's like goose and duck. And then this ROI head score thresh test. So this is just saying, don't count it as a detection unless you're 90% accurate. So if you're training a more complex data set, you might want to start and draw predictions out at 70% accuracy or confidence, just to see, because there's been cases where I'm like, my model is just not drawing anything out, and I forgot to lower this because the model wasn't as confident that it was going to be that object. So you might want to go to like 70, see how your model works, and then you can always adjust this again. So this right now is only going to draw a prediction if it's 90% confident that it's a goose. And then we're going to make a predictor variable here that we can then pass an image into. So let's run this. Let's run this. This is reading in an image that's from the test data set. And you can see it's returning, saying that's a tensor 0, which we'll talk about that in a second. But the Python, like most programming languages, index at 0. So 0 would be a goose because there's only one class. If you had a goose and duck, it could be a 0 or 1. So cool. If you did this, if you were able to get this far, you hopefully got a pretty awesome computer vision model that's doing really high accuracy on geese. So what does an image look like? I talked about how they're multi-dimensional arrays. You can see it's just a multi-dimensional Python array here with red, green, blue values. Let's print out the instance. So just to note, in PyTorch, there's a convention where you can say like 2 device, like 2 CPU, 2 GPU. So in this case, we're actually running the prediction on a GPU. And then when we write the visualization out or get the prediction numbers, we want to bring that back to our CPU. So that's what this is doing if you ever see that convention in PyTorch anywhere. So you can see this is saying it returned 2 instances, 2 predictions. And then here are the bounding boxes for those predictions. And that's actually what is drawing out those coordinates. So like I've actually built a custom visualizer library before. So like you get all these coordinates or the polygon coordinates, and then you use something like Pill or Pillow or OpenCV and draw those out manually. So you can do whatever you want, like change colors and stuff. So this is actually the really important stuff. Like for us humans, we love seeing this detection, but a lot of times you'd actually be making decisions about something by looking at these numbers. Like when I talked about interaction between instance segmentation and the virtual keyboard, you could say, well, I know the keyboard is in this location in the image, and I can now see that these numbers are overlapping with each other, so maybe that counts as a key press. And then you can see the confidence score here at about 99 for each of those, and the predicted classes, which again, they're both 0 because we only have one class here and it indexes 0. So here, just a tiny little bit of code. We can say, we detected 2 geese. And this is something that people actually want sometimes. Like if you're monitoring a room or some sort of area, like you want to see how much wildlife is there or how many people are in a room, you can actually do that just doing with something like this, like object detection, not even too much of a layer afterwards. You're literally just getting the count and returning it. So a common example case right now is with restaurants are supposed to only be at whatever percent capacity you're in, depending what state you're in. So if you are above 30 people or something, people walked in, you could have it do some sort of alert. Let's run it on another image. Again, there's a reason why they're photoshopped into my living room. I can talk about it later, or you can go read. I think I linked to the repo afterwards. So let me just go ahead and run these other code cells for the evaluation metrics. And we're actually almost done with most of the code here. And then I'll catch up on all those questions. So we're just going to import some stuff again from Detectron 2. This is doing evaluation. So it's bringing in our test data set now, not the validation data set, and then running the average precision on it again so we can see how good it did. So we're using Cocoa Evaluator, bringing in all that stuff. Loading in our test data set, and then we're just printing out what happened in there. So you can see it had 32 images in our test data set, and then it was still 79, almost 80 average precision, which is pretty good. And then these are kind of just various ways of reading average precision. And so I linked to some stuff in here. I'll share in the chat in case no one is in the notebook. But this goes much deeper into the evaluation and how you want to evaluate things. All right, so just a couple more code cells. So let's go ahead and actually just do this. This just displays a video. This is a goose video I took. So all the data sets I just made myself here. I just went to a park, got a whole bunch of pictures of geese, and then like this is a video, and now we're gonna run it on a video. And so you'll be able to do this with your own data set, run it on your own video, get a really cool visualization. And people love it, like if you share it out on LinkedIn, like if you're trying to get into computer vision or you're just like building a cool product, people love seeing computer vision visualizations. So we're going to do that here. We're going to pip install a library called YouTube Download. So it allows us to download my YouTube video. We're going to download it as video.mp4. Here, we don't actually use this, but I did include this code cell because sometimes if I'm running this on a video that's like several minutes long, it can take a long time to run the visualization on every single frame. And I want to do a test set. So I would make like a 6-second clip. And if I do this right now, it'll save this video at videoclip.mp4. And I can just copy that file name and replace this part with it, but I'm going to run on the full video here. But I wanted to note, so if you're doing something on like a video that's minutes long and it takes a long time to write out this visualization, it's good to test it with like a 6-second clip to make sure it's actually working how you want it, and then run the entire thing. Let's go ahead and run this cell, and I'll talk about what it's doing. So it'll take a little bit to run. You should see this little progress bar down here. We're importing some stuff from Detectron 2 again, the video visualizer, image visualizer, and then we're saying video capture. We're bringing in that video that we just downloaded, getting some stuff from it like width and frame rates, nothing too crazy. We're creating a variable called video writer using OpenCV's video writer function, and we're gonna write the video as out.mp4, and then you have some stuff that you could set like the frame rate and width and height. In this case, we got those up here, and then we're just making it the same size. We're saving it as MP4. We're making this variable v for video visualizer. Again, that's from Detectron 2, so it just makes it really easy to write out those predictions as cool visuals. And then here's a function that's run model on video. We're going to pass it video and the max number of frames, which is how many frames were in the video. And then essentially, this is just a while loop and saying, well, there's still frames left in this video. Take the frame and pass it into our predictor function, and that's going to return those instances like we saw before. And then we can draw them out with the visualization in OpenCV. And then we're just yielding that frame out of the loop. And then once the frame that it just did on is equal to like the last frame of the video, then it will stop the loop. So now we're calling that function here. We get this cool little progress bar from the TQDM Python library. It's really neat if you need to write out progress bars. It's a library I recommend checking out. And then once this is done, you can run this last code cell here, and this will download the video. And this can take a minute. Let me know, did this work for anyone else? Are you downloading your video with a model on it? So once it's downloading, fingers crossed, hopefully you're gonna have an awesome computer vision model to show off. And now you have the knowledge to go build your own model with your own data set. And obviously, if you're new to it or anything like that, new to the field, there could be a lot to learn, and maybe things were like, oh, I don't quite know what that was, but you're in a pretty good place. Like it took me a long time when I was learning computer vision to get to this point of like knowing how to label a data set and bringing it into model. It's actually why I made this workshop in the first place, because I was like, I think there's a better way to just get started with object detection, not just doing classification. So you can see here, it's actually running on the video and doing a great job of detecting those geese. So did anyone else get that? Hopefully you got a cool output there, and you went through the entire kind of steps of understanding how to label a data set and then train a model and then run that model on images, get kind of the returned output, and then actually write those out as visualizations, which is really, really cool. And all in under 2 hours, which is super exciting. So again, I know some of it might have been fast, so it's okay to be like, ooh, I didn't quite get everything, just depending on your background. But hopefully you learned something new and you're more excited about computer vision. And then I'll be hanging out and answering questions for a little bit if you want me to go back through anything. But otherwise, here's kind of the links you can stay connected with me at. And I really hope you had fun, and I do hope you learned something new. And there's some other links down here. So if you want to go deeper into like single shot multi-box detection or YOLO networks or anything like that, I have good links here, as well as some other resources. Like PyImage Search is a great website to continue learning about computer vision, and same with machine learning mastery. Cool. Any questions from everyone? Or first of all, you could let me know. Hopefully you had fun and you got through the entire thing, and you trained a model and you're excited about it. I said it was really nice. Thanks a bunch. No problem. It was super fun. I always enjoy doing these workshops. So cool seeing people from all these different backgrounds too, and then you're actually able to go through and know kind of, again, maybe it's a high level in some of the areas, but all the steps to go through and start building your own computer vision models. Let me know, or let me catch up on some of the questions. I know there were some before, so I'm going to scroll up a little bit, but also feel free to put new questions in the chat right now. Someone asked how long this will be available. The notebook should be there. I plan on keeping it up. So if that's what you're talking about, then it should be up and you should be able to copy it. And then same with the data annotation. So it could be about that potentially too. The data annotation side, there's the free kind of version you should be in if that's what you're asking about. We're actually changing pricing very soon on it. So I don't want to give you an answer and then it change right away, but there should be a free allotment of like labels you can use. That's quite a bit for kind of any hobby project. but I can get back to you on the exact number. The only reason is because it's like changing right now, but it's not in the UI yet, I think. So. All right, I'm going to scroll up, and yeah, feel free to put any questions in that you have in the chat, because it's always really fun hearing what people thought, or what they're looking to do next. I'm also down with if we want to stop recording and then just kind of hang out and answer the questions.
I wanted to keep recording for a bit, just in case people are watching YouTube later. That's why. But they can send a chat, or you can. Which would you prefer from now? Is there any other public questions people would like to ask?
Yeah, if you just have anything else in the chat. Let's see. Oh, someone asked, did I run on a GPU? I did run on a GPU. They said CPU and it went really fast. Sorry, I might have scrolled up really far. Someone says, for models older than detection, is it common to train an image classifier first? Older than detection. I'm not quite sure what that means, or is it usually all in one? Oh, so there are different ways. I mean, it depends on your data and how you want to architect things and or organize your data. Because I've done some cases, which maybe you're talking about, where I would create a label. So I was actually working on a project where we were detecting like, well, let's say like we wanted to detect, I don't know what a good example is, but like, we'll say a coffee pot. This is a dumb example. Say we want to detect all coffee pots in a object detector. And so I can hit save as my label. But then once we detect a coffee pot, we want to detect, like do regression or classification of how full the coffee pot is. So we could actually add a sub-label and do classification here. And then I would have options, like let's say I had just for sake of making this fast, let's say I only had like a 3-cup coffee maker, which would be pretty small. So I would hit save coffee fill, hit save. And then I don't actually have a picture of a coffee pot here, but let me go back into our demo folder, back to our labeler. Again, it's showing 0 images because there's no more pending. So I'm going to go back to all images. And then let's just say that this goose, for the sake of argument, is a coffee pot. So I could label this as an object, and then you get a sub-label in there. So we could say it's like this coffee pot happens to have 2 cups of coffee in it. Then I could hit done. And then what this does is then you need to understand how you would break that apart for your model needs. So like one way of doing this is you could have a 2-stage approach, which is the first that comes off the top of my head. There's always different ways of doing things, but I would have a model that detects coffee pots, and then it would, once it did that, then it would run a classification model just in that bounding box, and then get the kind of classification of how many cups of coffee. Hope that answers your question. Kind of sounded like maybe that's what you're asking. Oh, someone asked, oh, you found my YouTube channel? Cool. Yeah, I'll share those links again, just in case if anyone wants them. They're at the end of the notebook as well. So if you ever like, where was anything? Everything should be in here. Greg is inserting applause sounds. Applause for you. Also applause for all of you. Again, especially if you've never done anything like computer vision, or if you've never done it at this level of like making a data set or object detection. It's super awesome. I know like the first time I've done things like this, it's just like, ah, so cool. And I want to do more things. So again, too, if you do train your own data or if you train your own model on your own data set, I always love to see it. It's always really cool to see what people build afterwards. Like someone shared a really cool thing and tagged me on LinkedIn the other day where they were using it to detect like architecture stuff, which was awesome. And like, I think like defects in roads or something. It's really cool. Also, was there anything else like any of the other organizers wanted to talk about? Again, I know you have upcoming events. I don't know if you want to reiterate those.
Did want to remind people about the SIGGRAPH conference coming up in August. So that'll be virtual.
Is that on your meetup as well?
Yes. Links to the other site. Yes.
Just grab your meetup real quick again. Just share that in the chat as well. In case anyone came in through one of the other channels or anything, that is the SIGGRAPH meetup. So if you want to see more cool talks like this or other cool stuff coming up, the virtual conference is August, it looks like.
SF Bay ACM is also a joint event, and they have a lot of data science. I also posted in the comments for this meetup Stanford events. Next one is dealing with scene graphs, so it's kind of higher level analysis of photographs, and they're trying to learn beyond what is trained.
Awesome, very cool.
I think one of our audience asked if all these resources will be available, and the answer to that is yes. Through a follow-up email, all the resources will be sent to you, including a YouTube link to this recording.
Yeah, thank you. Yeah, I guess I don't have them in here, but I can send the organizers a link to the slides as well, so those can get included if you want to go through any of them. Most of the stuff is really just, using the labeling tool and then using this Colab notebook, I think, are the important things. But if you did want to review anything in the slides, we can send those out too. Other than that, if there aren't any other questions or anything, I mean, that is all I have prepared for you. So again, I hope you had fun. I hope you learned something new. And if I pass it back to you, Simon, or sorry, Brent.
I am allowing people to unmute themselves. Greg, if you want to announce the 2 events you listed there.
Yes, there's a couple of events I posted on the channel. They weren't organized by SF Bay ACM, but might be of interest to this crowd. So there's an Embedded Vision Summit that's coming up in May, and also in, I think it's August or September, there's the regular Data Science Conference, KDD 2021 is going to be August 14th to 18th. So that's going to be virtual. That was originally in, I think, Singapore, but they converted to virtual. So that would be easier to attend as well.
Also is the NVIDIA conference. They have many free seminars on there, some related to computer vision.
Yeah, the GTC last week was very good.
Okay, I'm going to stop the recording. Or, well, actually, Brent, can you close out the meeting here?
Sure. Sage, would you like to answer this last question in the chat?
It says, as an architecture, what kind of technique you think we can bring on the table that CS people are less experienced, probably in them comparing to us? As an architecture, what kind of technique? I'm not quite sure what you're asking, actually, or I'm reading the question weird in my head.
I'm not sure how to ask the question. I don't know. For example, for the engine, if there is a, we have our knowledge is visual, and so we can design an engine that is visually more, have a better taste, or I would say. But I'm starting from zero, so I'm not that much experienced in that. So I was wondering what kind of technique I can bring on the table. So I put much more time on that part.
For like the computer vision side of architecture?
Yeah.
Oh yeah, so I mean that's like a whole thing that a lot of people are working on, is like researching like how to build them better or make new ones. So if you haven't like done anything like that, it's really fun to just kind of read papers about it. If you haven't read any kind of research papers, there's Archive Sanity, which links to really interesting archive machine learning papers. A lot of them are in computer vision right now. And there's also papers with code, And these are all kind of like typically cutting edge stuff that's like coming out right now, and from people's research. And there's a lot of different ways of like building models. If you've never done it before, you could also, I'll have to dig it up, and I'll have a link right off the top of my head, but there's some good blog posts about like using TensorFlow and implementing architecture. So like in this case, we just kind of imported one, and it's like, cool, but you can actually build them from scratch. So if you've never done that before, that's a good place to get started as well. Like build a common one from scratch that you know is going to work well, or a small one. And then like a lot of big companies have researchers that actually work on this as a problem, like how to make an architecture that performs better for their problem.
Cool. I will give you updates about it.
Cool.
I hope I can do something. Yeah, thank you.
All right. Okay. Looks like we're finished with the meeting. So thank you everyone for joining in this workshop. I hope you learned a lot. We'll send up a follow-up email regarding the resources and the YouTube link. So yeah, please stick around if you want to ask more questions. But yeah, you guys are free to go.
You're released.
And round of applause for Sage.
Yeah, thank you all for coming. It's really fun.
Thank you very much. Do you go to kaggle.com at all for the competitions?
I don't go too much. There's some I was looking at, but I really haven't done a ton of Kaggle. Do you? Have you? Does anyone else do a lot of Kaggle stuff?
Some, but not as much lately.
There was one I wanted to do, but I just didn't get in the mindset for it. That was really cool with like medical imagery and like object detection for various things. But it was like seemed like a really cool data set. But for anyone who didn't, I will share Kaggle in the chat. But it's just a cool machine learning kind of website. There's a lot of data sets, a lot of notebooks that you can kind of like we did with Colab. You can do machine learning just through the browser. It's a good place to get started too. Still 16 people here. I don't know what you're expecting, but I don't have anything more for you. Yeah, if you do have any other final questions, feel free to put them in the chat. And thank you for coming. Someone said they were in and out of the event. Oh, you should have the recording, so you will be able to catch up.